A warm greetings to one and all. In this session, let's learn about features of OOPs. The topics to be covered in this session are introduction to features of OOPs, class, objects, abstraction, encapsulation, inheritance, polymorphism, dynamic binding, and message passing. As a part of introduction, we all know that object-oriented programming, as name suggests, it uses object-end programming. Object-oriented programming mainly aims to implement real-world entities like inheritance, hiding, polymorphism, and encapsulation, and so on. The main aim of object-oriented programming is to bind together the data and the function that operate on them so that no other part of the code can access this data except that function. There are some basic concepts that act as the building blocks of OOPs. They are classes, objects, abstraction, encapsulation, inheritance, polymorphism, dynamic binding, and finally message passing. Next, objects. Object is an actual entity which has physical existence in a real world. One object should be distinguished from other object. The picture represents the analogy of a blueprint to a home. As we know, the blueprint represents a class. Each home built based on this blueprint corresponds to an object representing a specific instance with its unique characteristics. Yes, this object is called as house, this object is called as bungalow, and this object is called as hut. Just as multiple homes can be constructed from a same blueprint, multiple objects can be instantiated from a same class, each with its own state but sharing the same behavior by defining the class. Creating object is mandatory to make use of a members of class. Each object is an instance of a class. For every object, memory will be created separately, and every object has attributes, behavior, and identity. Attributes holds its own value, behavior performs certain functions, identity has unique ID for its physical existence in the real world. Data or variable which is defined within a class is called as instance variable, which is used to store the attributes of the objects. When a class is defined, no memory is being allocated to it, but when it is instantiated, a memory is being allocated. Next, abstraction. Abstraction is one of the most essential and important features of object-oriented programming. Data abstraction refers to providing only essential information about the data to the outside world and hiding the background details or implementation. The picture represents the analogy of abstraction. Abstraction is like being a driver who only knows how to operate a car without needing to understand its internal mechanics or how to repair it if a problem occurs. Just as a driver interacts with the car through its interfaces such as steering wheel, pedals, and dashboards, as a user interacts with an object through its public method without needing to know the underlying implementation details. The advantage of abstraction is that every user will get his own view of data according to his requirements, and he will not get confusion with unnecessary data. Next, encapsulation. Encapsulation is nothing but wrapping up of data and information in a single unit. Encapsulation is defined as binding together the data and the functions that manipulate them. So the picture depicts the class where class consists of data members and methods. So wrapping up of variables and methods into a single unit, which is called as class, is called as encapsulation. So the picture depicts the encapsulation. Encapsulation mainly improves readability, maintainability, and security by grouping data and methods together. Next, inheritance. It is the process of acquiring the properties of one class to another class. The picture depicts inheritance. Father represents parent class and son represents the child class. Here, son inherits the properties like character, color, eyes, and etc. from his father. So it is essentially creating a parent-child relationship between the classes. Inheritance mainly focused on code reusability and maintainability. The class from where properties are inherited is known as superclass, and the class to which properties are inherited is also known as subclass. Next, polymorphism. Polymorphism means one name, many form. The picture depicts the analogy of polymorphism. Here, a person exhibits different roles in various situations. For example, a person can act as a family man at home, a customer while he is shopping, and an employee where he is working, or a boss in a managerial position. Similarly, the polymorphism is a concept where an object behaves differently in different situations. It simply means that one function can be used for multiple operations without declaring a different function. Dynamic binding refers to the linking of a procedure call to the code to be executed in response to the call. Dynamic binding means the call associated with a given procedure call is not known until the time of call at runtime. Here is an analogy for dynamic binding where a person assumes a different role dynamically based on the context. A person acting as a customer in a shop and a person may act as a passenger in a vehicle. A person may act as a student in a class or he may act as a son at home. Similarly, in object-oriented programming, dynamic binding allows a method to call to be resolved at runtime based on the actual type of the object. So it enables flexibility and adaptability in behavior of the object depending upon the context in which they are being used. It is associated with inheritance and polymorphism. Dynamic binding is also called as late binding. Finally, message passing. So it refers to the process of passing a message or a data between different objects or components in a program. In this picture, there are four objects, namely object 1, object 2, object 3, and object 4. Each object has methods and data of its own. So if one object wants to communicate with other object, it is done via passing a message. Usually, this is done in function call. So hope you all are clear on features of object-oriented programming. Thank you all.